Hello and welcome to this quick take video, an introduction to Xilinx's QEMU. The purpose of this quick take video is to help you understand what QEMU is, how it works, and how you can use it to accelerate your development and to reduce your costs. Let's jump right into the basics. QEMU is a functionally accurate virtual emulation platform. This means you can use it to develop, debug, run your software as you would do on your actual development board using exactly the same development tools. However, since it's a virtual emulation platform, it runs entirely on your laptop. It means you don't have to carry around boards and cables. Moreover, it is really easy to deploy across many developers. Can you imagine trying to deploy tens or hundreds of boards across your development team? With QEMU, your laptop is all you really need. Xilinx's QEMU connects all the system pieces together for you. Taken as an example, Zynq Ultrascale plus MPSoC, you can run simultaneously all the 4 ARM A53 cores and or both the ARM R5 cores, including the various peripherals in the hardened processing system. This gives you the ability to develop across different subsystems and their interactions. As of a 2016.3 release, and based on Xilinx innovations, you can interface your software transparently with models of your programmable logic IP as well as various board devices. So we really are pulling everything together for you. This is a truly powerful emulation platform. Your software components, like your kernel, drivers, frameworks, and applications, are unaware that they're running on a virtual emulation platform. We mentioned that QEMU is a functionally accurate virtual emulation platform. It means it's accurate at instruction level rather than clock cycle level. This key point makes Xilinx's QEMU execute really fast and is simple to extend. As an example, loading and running a full Linux kernel on our Zynq Ultrascale plus MPSoC QEMU model takes less than 20 seconds. For software stacks not utilizing a full operating system, it's much faster than that. Here's some more good news. Xilinx QEMU is open source, which means your investment can go a long way by utilizing open source and industry standards. You are not locked into a vendor solution. We work constantly with the open source community. Xilinx QEMU is completely free and is supported by Xilinx. Now that we know what QEMU is, let's take a quick peek under the hood. Let's see what drives this powerful emulation engine. Having a high-level understanding of how QEMU works provides us with a unique perspective as to how we can best use it to reduce our time, effort, and cost across our development operations. You code your solution exactly as you would do on your final target platform, just like the code fragments shown here. To produce your binary executable, you compile and build your code using exactly the same compiler, linker, libraries as you would do on your final target platform. Once you have your binary executable, you download it, run it, debug it, like you would do on your final target platform. Let's assume, for the purpose of this example, your binary executable runs on the ARM A53 core, which supports the ARM v8 instruction set. Although for this purpose we use the ARM A53 core, with Xilinx's QEMU you can also target ARM's A9s and R5 cores, which support the ARM v7 instruction set, or Xilinx's Microblaze, which supports the Microblaze instruction set. But just to keep things simple for now, let's stick to the ARM v8 for the ARM A53 core. Once you load and run the executable behind the scenes and transparently, QEMU's emulation engine will take the ARM v8 instruction opcode and operands and will convert them on the fly to the equivalent x86 instruction, which will execute on your laptop's processor. The result of that instruction execution, the operand values, and the system state will be reflected back into the ARM v8 execution context. This is a very powerful approach. It enables you to take full advantage of your laptop's powerful processor, which means the emulation execution is really fast. Furthermore, and perhaps far more importantly, the executable running on QEMU is totally unaware that it's running on an emulation platform. So you could in fact take the very same executable and launch it as is on your target platform without any changes. In our illustration, we keep things simple. We're not showing in our diagram the multiple SoC peripherals and board controller models Xilinx's QEMU supports. We will take a closer look on these capabilities in subsequent quick take videos. So now that we have a basic understanding of what QEMU is and how it works, let's take a closer look on how we can make it really work for you. Over the years, having used QEMU extensively at Xilinx and from talking to our customers, a few key development methodologies have emerged that drastically reduce development effort and project costs. As you might have guessed, there are no silver bullets. It's all about a systematic approach to modeling and integrate our system's most architecturally significant components early and continuously. As developers, architects, and verification engineers, we all know that trying to solve behavioral integration issues towards the end of our project is a recipe for disaster. Late integration bugs are difficult to find, and the longer it takes for us to find them, the more costly they become. Not to mention they can derail entire projects. That is all good and well, you might think. But in reality, you cannot integrate early and continuously, because different teams deliver their different components at different times. How do you even begin to develop software for a programmable IP logic that is not yet available? Or consider the other side of the same coin. How do you develop programmable logic IP when you don't have the software that will drive it? Unit testing the IP is good and is always required. Unfortunately, the serious problems show up when you put everything together. But what if we had a tool that we can use to quickly model and integrate the software and the programmable IP logic functionality without the modeling complications of time accuracy? After all, we always need to make sure the behavior of our system is correct before we can stress it for performance. Well, that's exactly what QEMU delivers. As a software engineer, you can develop your entire software stack without having to wait for final RTL-based IP, device, or board to be ready. As a system architect, you can start modeling the entire system easily. Your main focus is to ensure the functionality of your design is solid. It meets specification before you commit to performance. As an IP developer, you can develop your validation tests that target the IP's functionality far beyond the basic transactional unit test. You can now test your IP state machine using exactly the same software drivers as you have on the final target system. It's not by accident that Xilinx has delivered successfully 3 generations of products ahead of its competition. As an example, it took us just a few hours from powering up the Zynq Ultrascale Plus MPSoC for the very first time to the first Linux prompt. Xilinx QEMU was part of that success. We believe QEMU is another tool that can help you deliver success for very robust and complex systems. And remember, Xilinx QEMU is open source and driven by industry standards, so you can take advantage of your investment in subsequent projects. Xilinx has made some key innovations in its QEMU models. As we previously mentioned, we pull everything together for you. Xilinx's QEMU supports our most powerful devices, such as the Zynq Ultrascale Plus MPSoC, a true heterogeneous multi-core SoC with a powerful programmable logic fabric. As of our 2016.3 release, you can model and co-simulate your programmable logic IP and software stack using systemcTLM, a widely supported industry standard for modeling hardware components. We want you to focus on solving your problems and know how to integrate our tools into your build flow. That's why we provide Yocto support for our QEMU. In a virtual emulation platform, you have a finer control of events and execution. Therefore, you can really simulate quite difficult corner case scenarios that are otherwise very difficult to induce in the final target platform. For instance, consider our non-intrusive fault injection API. It is ideal for security and safety-oriented applications. Moreover, you don't need to know much about QEMU to use it. It is fully integrated in Xilinx's SDK, so you're only one button click away from being able to run your application on it. However, if you prefer, you can launch it from the command line. It is entirely up to you. QEMU from Xilinx supports Xilinx's Microblaze softcore IP, Zynq 7000, and our Zynq Ultrascale MPSoC. As we mentioned previously, QEMU is an open source project. However, Xilinx's fast-pacing innovation requires fast delivery mechanisms. Therefore, Xilinx packages and delivers QEMU with our innovations. And even though Xilinx packages and delivers QEMU, we're still working continuously with the open source community to pull and push features to and from the QEMU mainline open source project. To summarize what we learned today, with Xilinx QEMU you can develop, integrate, validate your software stack and hardware IP right from the get-go. Simulate corner cases for your software stack and IP not easily reproducible in silicon. Use open source and industry standards to safeguard your investment. We would encourage you to try QEMU now at www.wiki.xilinx.com/QEMU. This completes this quick take video introducing Xilinx QEMU. Thank you for your time.